So now that you've had a chance to see how to visualize Java futures, how to program Java futures, let's take a look at the pros and cons of using Java futures as an asynchronous computation mechanism. And we'll see that there's some good things and a bunch of things that are problems, drawbacks, limitations. So let's start out with the good stuff. So one nice thing about Java futures is you may be able to leverage parallelism more effectively with a fewer number of threads than if you'd done a bunch of two-way calls that were synchronous using threads for those, where you'd have lots of threads. The way this typically works, as you saw, is you queue some async computation to be executed in a pool of threads. So you submit something that's going to take a while to run in the background. And the nice thing about doing this is, depending, of course, on what kind of thread pool you use, if you use a cached thread pool, it'll auto-tune itself to the number of threads based on the number of computations that are currently pending to be run. There's other thread pools, such as the common fork join pool, that can give the same effect if you combine them with managed blockers, as we've talked about before. A fixed thread pool will always have the same number of threads, but there's some that can attune themselves, which is kind of cool. And then, at least for the executor completion service variant of all this stuff, you can get the results from a queue of completed futures. So as the futures finish running, or the computations finish running, the completed results are stuck onto something called a completion queue, and then those results can be plucked out by take, and then you can go ahead and get the results. So in this particular model, the take call might block if there aren't any futures ready for consumption, but the get call will not block because we wouldn't have, it wouldn't have gotten on the queue if it wasn't finished. So there's no blocking here. We just need this for syntactic reasons in order to be able to know whether the call succeeded or failed. If it failed, we get an exception. If it succeeds, we get the results back. The other nice thing, using the word nice thing here in quotes, is you can block until the result of an async two-way task is ready for your consumption. And you can see there's two different methods, get and get with the timeout. So using the timeout might make your program a bit more responsive, because you don't have to sit around just waiting incessantly for things to finish. You can have them wait for a certain amount of time. You can also do some other stuff, as we saw before. You can see whether something's finished. You can see whether the computation is finished. You can see whether the computation is canceled. You can cancel a computation, et cetera, et cetera, et cetera. And the ability to check for cancellation and to cancel may make your program more efficient and responsive, because that way you don't block. If somebody decides to shut something down, and let's say you're running in a GUI and you're tired of the computation, you click the little cancel button, that'll shut things down. You don't have to wait for everything to finish on its own. So it can be more responsive. But of course, not everything is unicorns and rainbows. So there are downsides with Java futures as well. There's some cons or some drawbacks or limitations. Probably the biggest problem with the futures is that the feature set itself is very limited. You've only got these 5 methods, and they have a bunch of limitations, mostly having to do with the fact that, well, with the things we're about to talk about. There's about 4 things that make them limited. One problem is that futures cannot be completed explicitly. You have to use some other mechanism, such as the Java future task, in order to complete them. And so that makes them more complicated, and the average retail user may or may not know how to use future task as readily as you might want, and so it just makes things complicated. Another problem, big problem, is you cannot chain the results of future calls fluently. Remember how we've talked before about the fluent interface pattern, and how you can do things like with Java streams, where you can make a stream, you can filter, you can map, you can sort, you can flat map, you can take while, you can limit, et cetera. Those are all things you can chain together. Well, there's no convenient way of being able to chain together the operations on Java futures. So that dependent actions can't be triggered to handle the results of async processing. You have to sort of do things one step at a time, and it just gets ugly and awkward very quickly. Another problem, which is somewhat related to the previous problem, is you can't trigger futures reactively. The client has to explicitly call either call get or call timed get versus poll get, the thing here where we put in 2 zeros, that's the poll get version versus the time get version versus the blocking get version. And what that means is a calling thread can only wait for one future to complete at a time. You can't trigger these things reactively. And you may wonder, what the heck does that mean? We'll talk about that. It's very, very, very important. It's almost always incorrect to have timed waits on futures. Even though it's a feature that's there, it's probably better than blocking indefinitely. But whenever you start finding yourself putting timeouts, it's probably wrong. And you can read more about this, timeouts, about how timeouts are going to get you into trouble. And then another thing you can't do is you can't treat a bunch of futures conveniently as a collection. Now, there are ways to do this if you use certain things like the executor completion service, invoke any or invoke all methods, but that gets you off into a much more complicated world and somewhat inefficient world. So the problem here is if you have a couple of calls and you get back a couple of futures, you can't say, tell me whichever one comes back first. That's the one I want first, followed by the next one. You have to decide in order. You have to say, I'm going to wait for future 1 first, followed by future 2. Or I'm going to wait for future 2 first, followed by future 1. It's difficult to say I'm going to wait for them in any order. You can sort of do it if you use these other mechanisms, but it's cumbersome. So the bottom line is it's awkward and inefficient to try to compose multiple futures together. And of course, solving all those limitations, all 4 of those things that can go awry, all the quirks of futures, is precisely what motivated the need for Java completable futures, which is going to fix all of these problems. And that's what we're going to talk about next, now that we've wrapped up our discussion of the pros and cons of Java futures.